Already we have seen time response of second order underdamped system. Then we have seen time domain specifications. Based on that, we are going to see some problems. A second order mechanical system is represented by the transfer function theta of s upon I of s equal to 1 upon a step input of 10 Newton meter is applied to the system and the results are given below. The maximum overshoot is 6%. Maximum overshoot is 6%. MP. MP equal to what? 6%. Therefore, 100 e power minus zeta pi upon square root of 1 minus zeta square. That is equal to 6%. Time at peak overshoot, TP, equal to 1 second. TP, what is the formula? What is the formula? Pi upon omega n square root of 1 minus zeta square. That is equal to 1 second. Steady state value of the output, theta steady state. Steady state value of the output equal to 0.5 radians. It means second order mechanical system, we do not know the nature of the system, whether it is underdamped, overdamped, critically damped, undamped. It is not undamped because it is settled at 0.5. Therefore, any one of these three categories, overdamped, underdamped, critically damped, it is settled somewhere. Let us assume that it is underdamped, it is settled somewhere. That value is 0.5. That is given. Finally, it is settled at 0.5. The steady state value of the output is 0.5 radians. This is given here. Determine the value of J, F and K. Determine the value of J, F and K. First, it is given that MP equal to, that is 100 e power minus zeta pi upon square root of 1 minus zeta square equal to 6. From that, we can find zeta. So, this can also be written as e power minus zeta pi upon square root of 1 minus zeta square equal to 0.06 or minus zeta pi upon square root of 1 minus zeta square equal to ln of 0.06. So now we have to find zeta square. What is the value of this? Equal to minus 2.8134. So both the minus signs getting cancelled. Therefore, zeta square pi square upon 1 minus zeta square equal to 2.8134 whole square. Find zeta. .667. Zeta equal to 0.667. This implies zeta square pi square equal to 2.8134 whole square minus zeta square 2.8134 square. From this, we can find zeta. Zeta equal to 0.67. Therefore, underdamped, what we have assumed is correct. Underdamped system. Underdamped system. Then time at the peak overshoot, TP equal to TP equal to 1 second. That is, this is first part. The second part is pi upon omega n square root of 1 minus zeta square equal to 1. Already we know the value of zeta. Therefore, we can find omega n. Omega n equal to pi upon square root of 1 minus zeta square. We know zeta 0.667. Find omega n. Find omega n. $4.217. 4.217 omega n. Now we have to compare steady state value. Steady state value theta SS equal to 0.5, that is given. For what? Input 10 newtons per second. It is given that theta of S upon I of S equal to 1 upon J square S square plus Fs plus K. I of S is given. I of S equal to what? I of S equal to 10 upon S. Because step input means if we take Laplace transform for that step input 10 upon S you will get. Therefore, I of S equal to 10 upon S. If you substitute this here, what you will get is theta of S equal to 10 upon S multiplied by J square S square plus Fs plus K. That is theta. We have to find final value. We know the final value theorem. What is final value theorem? You studied in signals and systems. J. Yes. Thank you. J. Final value theorem states that y of infinity equal to, or we can write like this. Limit t tends to infinity, y of t equal to, we can say y of infinity also. Limit t tends to infinity, y of t equal to, that is the final value, equal to limit s tends to 0, s y of s. If you know y of s, we can find y of infinity, that is equal to y of infinity. Here I am using caps y in S domain. In time domain, I am using small y. We can find y of infinity by using this final value theorem. So here we know theta of S. Theta steady state means equal to limit t tends to infinity, t tends to infinity, theta of t, that is equal to limit s tends to 0, s theta of s, by using final value theorem. Limit t tends to infinity, theta of t equal to limit s tends to 0, s theta of s. That is final value theorem. So if you apply that final value theorem here, we will get theta of infinity. Theta of infinity equal to limit s tends to 0, s multiplied by 10 upon s js square plus fs plus k. These two getting cancelled. S getting cancelled. If you substitute s equal to 0 here, what you will get? 10 upon k you will get. This is given. The value is given. What is that? Steady state value is 0.5 radians. It is given. Therefore, 10 by k equal to 0.5. 10 by k equal to 0.5. Theta of infinity equal to limit s tends to 0, s theta of s. Theta of s equal to what? 10 upon s, j s square fs plus k. S getting cancelled. If you substitute s equal to 0, s equal to 0, this becomes 0 and this also becomes 0. Therefore, it is equal to 10 upon k. That is given. What is the value given? 0.5. That is 1 by 2. Therefore, k equal to 20. 10 upon k equal to 1 by 2. Therefore, k equal to 20. Now we got one answer. Find the value of k is asked. Find the value of k is asked. We found only we have to find the j and f we have to find. Determine the values of j, f and k. One unknown, that is k is we found. K we found. J and f we have to find. To find j and f, compare this transfer function with the standard one. Compare this transfer function with the standard one. What is standard transfer function? Omega n square upon s square plus 2 zeta omega n s plus omega n square equal to, what is given? 1 upon j s square plus f s plus k. Therefore, coefficient of s square must be 1. Here, coefficient of s square is not equal to 1. Therefore, we have to rewrite this as 1 by j whole divided by s square plus f upon j s plus k by j. Omega n square equal to k upon j. Omega n square equal to k upon j. One equation we got. 2 zeta omega n. 2 zeta omega n equal to f. F. Therefore, f by j. 2 zeta omega n equal to f by j. Therefore, we know zeta. We know zeta. This is second equation. This is second equation. That's all. From these two, already we know one value. Two equations we have, two unknowns we can find. Number of unknowns and number of equations are equal means we can find. Now, what is k? What is the value of k? K equal to 20. Therefore, we can substitute k value, zeta value. Whether we know zeta value 0.667, that is also we know. If we substitute that, we'll get j and f. We can find j and f. Find j and f. Because we know that k equal to 20 and zeta equal to 0.667 that we know. So find F and J. Omega n also we know, Sorry. What we found here, omega n. Omega n equal to 4.217. So these two we know, omega n we know, zeta we know. So we can find KJF. K by J equal to omega n square, that is 4.217 whole square. That is equal to that is equal to 20 by J, because K also we know 20. Therefore, J equal to 1.124. J equal to 1.124. F by J equal to 2 zeta omega n. 2 into 0.667 and omega n equal to 4.217. Therefore, J also we know, F upon J equal to 1.124 equal to 2 into 0.667 multiplied by 4.217. Therefore, F equal to 6.323 Newton per meter per second. This is a Dashport constant B equal to 6.323 Nm Newton per meter per second.